researcher at Optimum AI, and I welcome you all to the day two of the introductory course of machine learning in Gen AI. So yesterday we saw the about the libraries NumPy, Pandas, Matplotlib, and Seaborn. Today we'll be delving into what is machine learning, and we'll probably cover all the classical ML algorithms. So I hope my screen is visible to everyone. Can somebody confirm? Okay, thanks. So I'll be starting first with what is machine learning, what kind of algorithms we have. Then I'll go in depth to one real world or state problem, and I'll show you how do we execute different algorithms. I'll more focus more on the mathematical intuitions as once you get the idea, writing code is very easy using Python and everything is provided to you by various libraries. So I'll start first with introduction to what is machine learning. So what do we mean by the word machine learning? Can anyone post in chat? What is their understanding of machine learning? I would like to read uh, some of the answers. And meanwhile, I'll continue. So, according to Arthur Samuel, he says field of study that gives computers the ability to learn without being explicitly programmed. Now, this uh, definition might be difficult for few of you to understand. So, let's consider an example and we'll understand through that. So we all use Gmails or some account like Yahoo or anything, and we all receive mails on daily basis, right? So you see there are various categories in the mailbox. One is inbox, then there is primary, social, and there is one more category called as spam, right? So you see few of the mails. So some mails like you hit a lottery or you got this something for free, you won this prize. You see they are classified in the spam category, whereas the important mails, maybe your mails related to your job applications, they all come to your inbox. Now, how does this happen behind the scenes? So how does your Gmail account or your whatever you're using for the mail knows which mail is your spam, which is not a legitimate mail, and which mail is actually a legitimate mail. So this problem is solved using machine learning. So machine learning is basically making our computers smart enough so that they can solve a particular problem on their own without any human intervention. So it's similar to like you train someone for something, and then that person is able to do that task on their own. Earlier, what we were doing, like we were using traditional programming, the approach was that you gave the computer data, you told the computer that this is the program you need to execute. And what did the computer do? It used to do the processing required based on the data and the program, and it would return you the output. But using machine learning, what we actually do is we provide in the data and we tell that we're expecting this kind of output. Then computer will like learn itself on its own using the data and the output, and it will create like the program. And whenever you give that computer a new data, it will be able to execute that program and it will be able to give you that output. So that is what machine learning is about and how it differs from the traditional programming approach which we have. Now, before we even delve into what is machine learning, it's important for us to know some technical jargons. which are like widely or heavily used in machine learning. So we need to know what is the model first. So model is nothing but just a representation of the algorithm which the computer executes or whatever gets executed so that your system knows like whether to classify this mail as a spam or not. And in other words, we also call model as hypothesis. Then the second term is feature. So what do we understand by feature? Now, in order to teach your system, you need to basically give some data, right? You need to give some instances or you need to give some words. For example, if you give the word lottery, it it might be possible that it's a spam mail. So you teach computer that see, hey, if you see the word lottery in the mail, just classify it as spam. So these words or the the words or the feed columns like which you use in your data to give the your M model or the algorithm to make a model is are known as features. So eh, consider the case of us. Even if we want to like know what fruit it is, if suppose we have something in front of us, some fruit, we need to know its features. Like we need to know the color of the fruit, we need to know the smell of the fruit, or we can taste the fruit to tell us like what is this fruit. Similarly, if you're solving a problem, say you need to predict temperature of your city tomorrow. So you might need what has been the wind speed, what has been the humidity, what has been the indoor temperature, and then you using these features, you can make a model that gives you the prediction for the temperature or forecast the temperature in your city for coming days. So this is what we mean by feature. I'll also show you in code what does this features or models and all these mean. Now, target is something which we want our model to predict. So, for example, if we take the example of a fruit, we wanted to predict what kind of fruit it is. So, suppose if the fruit was apple, then our target would be apple. Similarly, if considering the mail is a spam or not, if our target would be to predict whether the mail we've received is spam or not, right? So this is what we mean by target. Then we have training. Now you have a model, but how does your model know how to predict whether a mail is a spam or not, right? So for that, you need to train the model. Suppose you have a pet at your home, you basically need to train that pet so that that pet knows how to behave, how to sit, when to ask for food, um, to not shout in front if a lot of people, if your friends visit at your home. You basically train him, right? You train your pet to catch the ball when you throw the ball. So similarly, you need to train your model using the data. You train your model so that whenever there is a new data which the model has never seen before, the model can make predictions. Now, prediction, the word prediction, like we've been talking about this since past few minutes. So prediction is nothing but based on the inputs, whatever the output the model gives us is known as the prediction. So, just a hypothetical situation. You had the fruit, suppose the fruit in front of you was orange, but you saw it and you said it's an apple. So, apple that you said is a prediction, whereas in actual, the value, that fruit is orange. The prediction is what you told. Similarly, whatever model tells is the prediction. It might match the actual value or it might not match the actual value. So these are the terms which we must know before we even start talking about machine learning. So moving forward, we have types of machine learning. So the most common ones, the most famous ones are supervised, unsupervised, and semi-supervised learning. And there are also two other types of learning, which is self-supervised learning and reinforcement learning. So reinforcement learning would most probably be covered tomorrow. So today we'll be talking about the supervised and unsupervised learning. Now, what is supervised learning? So remember I gave you an example of predicting the temperature for your city. So in order to predict the temperature, you might need to know what is the pressure, what is the relative humidity, what is the wind direction. Then you predict the temperature. And if you observe, the temperature is a continuous value, right? So these kinds of prediction, um, where we have this data features as well as the target present. So basically, we need to provide a model, say temperatures that have been throughout mm, like 3 to 4 years, and then we can expect the model to learn and then predict the temperature for next 7 days. So supervised learning is a kind of learning where you need to provide both the input as well as the output parameter. And using these inputs and outputs, the model learns, and whenever if you give a new data point, if you give a new value of pressure, wind direction, and humidity, the model can make a prediction for the temperature. I can compare it to the classification whether the mail is spam or not. So, for example, in order to train your ML model, you give some examples where you give the examples whether this mail was spam or not. Now, using those examples, the model learns. The model has both the features as well as the output label. So you gave both features and output label to the models, and then the model learned from that data, and then the model is able to classify whatever new mails you're receiving as spam or not. So this kind of learning is known as unsupervised. It's known as supervised learning. Now we'll move to the next kind of learning. So yeah, I covered two examples like this spam one and the temperature one. Now, temperature, if you observe, it has some continuous values. So the model which we make to predict some continuous values are known as like regression problem statements, or we build regression models. And in case we are predicting some category, like we were predicting whether the mail is spam or not, so the output of this can be either yes or no. So these kinds of problems where we predict a particular category, they are known as classification problem. So like it's very intuitive. So we are basically classifying whether the mail is spam or not, right? So we call them as classification problems. Now there are a lot of supervised learning algorithms that do exist, but the most famous ones and the classical algorithms are linear regression, k-nearest neighbors, Gaussian naive Bayes, then decision trees, support vector machine, and random forest. So I'll cover all of them today itself. So let's move to unsupervised learning now. Now, unsupervised learning, to understand this, I'll not go through the technical definition. Rather, take an example. Suppose you are owner of a shop or a big mall, and you have lots of like uh, people visiting your shop or mall. Now, in order to boost your sales, you decide that you will keep some information regarding the people visiting your shop, like the customers that are visiting your shop or your big mall. So you like ask the person's name, you come to know about the person's salary, and you know whether the person has a credit card, like person makes the payment through credit card or debit card, and some like some these kinds of information. Now you have collected, suppose, a lot of information, say thousands or like 10,000, 20,000. Now you have this data, but is it of any use to you? So if you have such kind of data, it's like of no use until and unless using this data you extract some useful information or you identify some pattern. Now, suppose if you are very good at machine learning. So what will you do is that you will decide to build a model. And what your model will do is it will categorize it. It has this data and it will try to find out patterns in the data. And suppose if your model used the data and you built the model, and your model found out that there are basically two kinds of people, one who have very low income and the one who have very high income. And within the low income also there are two kinds of people. One are those people who don't make purchase or purchase very less amount of things, and the other are who are likely to make purchases, but they're somewhat hesitant, or they try to purchase those items that are like somewhat cheap. So, and then in like the people who have high income, in that also you have two categories of people. So one who always come and purchase every month from your shop, and the other who are less frequent visitors. Now, as the smart shopkeeper, what will you do? You, for the low people who are earning low, you'll try to introduce some discounts, right? You'll try to bring some schemes wherein you might offer some discounts, or you might say that on shopping of so and so amount, you will get this as a gift. So these kinds of patterns which you figured out, and using these patterns, you try to solve a business problem. So these problems are known as unsupervised learning. Now, the difference between supervised and unsupervised learning is that in supervised learning, you actually had the target variable also. You knew what was the temperature for the past 4 years. But in case of unsupervised learning, you just have the raw data and you need to figure out what you need to do with the data. So this is what is unsupervised learning. So data without labels, when it's given to a model, it's known as unsupervised learning. Now, within unsupervised learning, also we have two categories. One is clustering, and other is association. So, clustering is the example which I gave you right now, and this problem which I explained you is also known as customer segmentation, and it's a very classical clustering problem, which a lot of people tend to solve. So clustering, I give you the example customer segmentation, wherein you try to find out some patterns, like how likely the customer is to make a purchase from your shop, and you make decisions, business decisions according to that. Now, association. So just imagine like you visiting a big mall. Now, what you observe is that if you all have might noticed that if you go to the section where there are dairy products, you're more likely to find the breads and buns also present there, right? So, why is it so? Or if you are going to order burgers, if you are feeling hungry, you order burgers, you're more likely to order fries. You order pizza, you're more likely to order some cold drink. So this relationship which we have, like with burger, you tend to order fries, and if you're buying milk, you are like more tend to buy breads as well. So these kinds of like relations that we establish are known as association. So the kind of problem which we try to solve using association learning is basically we try to find relationship between things. So you might have observed this in like if you watch a movie on some online platforms like Netflix, then you are more likely to get a similar kind of movie recommendation, right? So this is what is association about. So I think I'm done with the theory. Yeah, semi-supervised learning. So semi-supervised learning is you have some unlabeled data and you have some labeled data, and using that you try to build a model. So a real life example would be, suppose you had your teacher in school, and one teacher gives you some homework, and you are expected to do that homework all by yourself. So You have no clue how to solve it. But there's another teacher who gives you homework and gives you some hints on the approach you need to take to solve the problem. So the teacher which is giving you some hints or holds your hands and helps you solve the problem, and then you're given the homework and then you try to figure out the things on your own. Now, this kind of problem is known as semi-supervised machine learning, and we use semi-supervised machine learning to solve such kind of use cases. So yeah, this is it for theory. Now, before we even start moving to ML algorithms, so I'll cover regression, classification, and clustering algorithms. So before I even start, so let us see, suppose if you're working in some company and you got a problem and you need to apply machine learning, how do you even approach the problem at the very first uh, place? Like if you have a problem, how do you go about that problem? And how do you think of applying the model, which model to use and all those things? So irrelevant of whatever you're doing, any kind of ML problem or AI problem or Gen AI problem, there are some certain steps. I've mentioned these 7 steps. So you need to know the spell. So first of all, if you have a client visiting you and he says that I want you to build a ML model to solve this problem. So suppose, just imagine you have some government official visiting at your home, and he says like you need to build a temperature prediction model for your city. So what you need to do is that say you need to gather the data, like you are given the responsibility to forecast temperature for your own city for the every 7 days. Like you need to predict today what is the temperature gonna be the next 7 days. So you got the problem statement right, but once you got the problem statement, you need to understand the problem well. You need to understand that what do you need to do? You need to predict the temperature. And for how many days? Like 7 days. You need to very well understand the problem. Now, the problem I took the example of temperature prediction is a very simple problem, but if you're working somewhere, you might come across a lot of difficult problems, and you might need to have interact with your client a lot of times to understand the problem well. Now, if you had the understanding of the problem well, you're done with the step one, which is problem formulation. So the next step is once you understood the problem well, what do you need to do? Now, how will the model know what problem you're going to solve? You need to have some data, right? Then only the then only you can build model or you can train your system to predict something. So for predicting the temperature in your city, what do you need? You need the data or you need the temperature for an entire year or for say 2 years, so that you can observe the patterns from the temperature. You can fed that data to your model and then the model can predict the temperature. So now how do you collect the data? So data can be collected from many different sources. You can have various sources of data, and data can either be very well structured like in the form of tables, or it can be unstructured, like it might be some like really hazy data. So you need to collect all the required data for your problem statement. So for example, I want to predict the temperature in my city. So what I'll do is I'll go online, search for some APIs that have the temperature data for my city. So for example, there is the Google Weather API. So I'll go through that, I'll collect some data, recent data of say from for past 3 to 4 years, and I'll store that data. Then there is Open Weather API as well. So like I collected data from different sources and I've collected a lot of data. So you're done with the second step as well. You have collected the data. Now comes the third step. Now you have the data with you and you've collected the data from a lot of sources. So the data would differ from each other, and there might be certain features or certain values used in data. For example, the data you collected from Google Weather API has some features, say what is the relative humidity, what is the wind pressure, and the data you collected from Open Weather API has some so other features like some any other temperature related features. So like what is the indoor temperature, what is the other like outdoor temperature, all these kinds of information. Now, in order to understand the data, you need to perform exploratory data analysis. What is it about? You have collected the data, but you haven't seen the data, and you don't know what kind of data it is. You need to understand the data well. Then only you can find out whether this data or this feature is even related to your problem statement. Is it going to help you solve the problem or not? So, for example, if you collected the weather data, but somehow you found out the number of people who live in
Uh,
that area.
Jyoti,
Um,
are you
yes.
switching the slides or still the
Oh,
same?
no, no. I have shared my notebook. Is it visible now? Just forgot.
Not visible.
Um, is it now? I think there is a. You can see regression collab notebook. Or let me read. Okay, just a second. I moved to collab. Yeah. So just I spoke the points. So this is what it is written. So we have covered till exploratory data analysis. So basically, you need to thanks Yaya for stopping me. Otherwise, I would have forgotten. Now, coming to exploratory data analysis, we need to gather some insights from the data which we have collected. So for gathering those insights, we need to perform EDA or also known as exploratory data analysis. So what we can do is we can plot some graphs or we can do some manipulations to the data. We can make new features out of the existing features and all these things. Now, once you have done this, the next step comes, you need to make, you have the data, you collected the data and you understood the data. Now comes the main part, which takes a lot of time. So basically, solving an ML problem doesn't takes a lot of time, like 80% of your time in doing the first four steps, which I've mentioned in the slide. And training a model comparatively takes lesser amount of time when it comes to solving the real world problems. So you need to process the data or you need to make the data ready to train your model or to give that data to the model. So how do you process the data and why is it even required? Now, suppose if you collected data from some online sources, there are high chances that you have missing data or you have some data that is uh, like this that is not properly scaled. And suppose if you have the data that is having string values, now, as you all know that computers only understand numbers like binary 0 and 1s. Similarly, our model can only understand numbers. It cannot understand any categorical data or any string value or any text. So you need to convert those categorical variables. For example, if you have wind speed and it's labeled as high or low or medium, computer doesn't know is what is high, what is low, and what is medium. So basically, you need to transform. Maybe high you assign it as 1, medium you assign it as 0, and low you assign -1. So these are the some steps which we go about in data processing. And now comes the main part. You need to choose and train a model. You made the data ready to be fed into the model. Then you train the model. And once you've trained your model, you need to evaluate that model. So basically, you need to test whether your model is performing well or not. So you evaluate your model. Now, if you found that your model is not doing very good, you might need to revert back to the fifth step. Now, this fifth and sixth, like these steps are iterative steps and cycle goes on until and unless you are satisfied with the model you have built. And once you're satisfied with your model you've built, you can deploy that model and then you can keep monitoring and then improving the model. 4 times in the coming years, and you can make it even more better. So now this is about uh, what I wanted to cover. Now this is all theory, which like you can go through this notebook in detail. Now what I'll do is I'll collect. I'll use this California housing data set, which I was using yesterday to explain you these libraries. And what this data set has, it basically has the data of all the blocks of the people residing in California, and we need to predict the median house value. So you see, we are importing all these libraries which we went through yesterday, and there is one new library, sklearn, also known as scikit-learn, and it's the most used library for solving ML problems. It has all the ML models built in. You just need to write one line of one piece of code to do something, and you only need to understand what you need to do. And code is very simple, like it's just one line code. You need to make proper imports, and you're ready to go with the code. So I'll import my data set as well. I'll import, so sklearn has some data sets present as well, so I'll just import it. Now, once I've imported the data set, I'll extract, like load the data, and I'll check what kind of data it is. So what I observe is that this data is already in the form of NumPy array, like n-dimensional array. But in real world, you won't have this data, right? You would have some random data. Maybe you have data stored in CSVs or in Excel. So what we'll do, we'll skip this part and we'll download the data from some online source. So suppose we have the data stored in the CSV file. So we'll just download this data from this link, and once we have downloaded the data, we this is the function which I've written to download the data. And it's a very simple function. It's just hitting this URL and getting that CSV file. And once you've downloaded the data successfully, we'll just create a data frame. So yesterday you saw like we stored the data in this data frame. So currently the data is stored in a data frame whose name is data. Now we'll proceed forward. We'll we have assigned this we're calling this function, and we've stored the data in this California underscore data variable. We need to know what the data is. We need to see. So we call the head method, and we see what are the first five rows, what kinds of values it has. So what you observe, it has these all features. And median house value, we need to predict the house value. This is our target. And you see one categorical variable also, like ocean proximity. You see that it is having string values. So you just make these kind of observations. Similarly, you can just print out some last five rows to even know the data better. Now here I've documented the information about what features we have. So longitude is basically how far the house is from the west direction, and latitude is how far the house is from the north direction. Then we have the median age of the house. Like if the age is higher, it means like it's an old building, and if it's a lower number, it's a new building. We have total number of rooms, bedrooms, populations. We have median income of the people residing in that block, and we need to predict the median house value. And this ocean proximity is basically the location of the house with respect to ocean, since the California is located on the sides of ocean. Now you knew this, you got to know about these features, information about what all column values you have. What you can do is you can just call the info method, and info method will tell you what are the data types and what are the non-null values in your data set, and what are the column values. So here you come to know that there are 20,640 rows, and you have 9 columns, like 10 columns, and one column is of object data type. Object basically like it is of string data type, and rest all are decimal point numbers, like floating numbers. And non-null count means these many rows are not null. So you see, all the rows are not null except for the total bedrooms. If you see, the non-null count is 20,433. what does it signifies is that you have these many rows, but actually the non-null count for this value, this total bedroom column is this. It means we have some missing data here. So you gather this information. Now, if you want to know the total number of rows, you can even call the len function. And if you want to know the total number of columns, you can call the len function on columns. So we have the total number of rows, total number of columns, what type of value does the column have. Now we'll come to our next step. We have understood the problem, we have collected the data. Now we'll come to exploratory data analysis. Now, the most important thing, like before we even start exploratory data analysis, in a real world, suppose if you've made the model, but you don't have any new data, you need to check like how the model is performing, right? It is good enough, or do you need to improve it even more? So you need some testing data as well. But you have only one. In my situation right now, I only have the CSV file. How do I find the testing data? So what do I do is whatever the data I have, I'll split the data set into two parts. One part which I'll give to the model, I'll call it as the training data set, and the other part which I'll use to evaluate the model, I'll call it as a testing data set. So in order to perform the split, what I can do it very simply. All I need is to import this train test split class from model selection library of scikit-learn, and then I just call this train test split method, and herein I pass this my data set, and I've given this test size as 0.1. Now, what does this mean? So 0.1 basically means 10%. You can multiply this number by 100. If you set it to 0.2, it means 20% of your data would be used as a testing data and 80% would be used as a training data. Another number which you see here is random state. So I've set random state to 20. So what does it means is, yesterday I explained you about random.c. So it's just same. Suppose if you're executing the same code in your machine and you want results to be similar as of mine. Otherwise, what will happen is this code on executing, it will make different splits. It will take some, say it took some values from the middle of the data set for me to create a testing data, but for you, it took the values from the end. But you want the training data and testing data to be same for like for even for me or even for you. So you can set this number the same which I've used. This is what is meant by random state. So once you have made the split, you'll do the exploratory data analysis on only the training data, and you'll not even see the testing data. So we don't need to, we need to act like we don't even have this at the very first place with us. We'll only use this test data once we have built our model. So this is how you can create testing data and training data once you have the data with yourself. Now what I've already explained you, like we've allocated 10% to the test data set. Now it's a good practice that we always create a copy of our training data so that if we mess things around, we can always get back our actual data and we don't mess up our actual data. Rather, we have created a copy of the data frame and we have kept that copy separately. So here I've created the copy separately, and now I can go and start my analysis. So these are all very minor steps, and these things are very important to know once you start go about building your ML models. I've covered all of them right now. Now we'll start our EDA or exploratory data analysis. The very first thing which we should do is we should run this describe method. And I've used transpose so that it's more readable. Now, if I call this describe method, it gives us all the like statistic values, like what is the total count, what are the unique values, what are the top values, what is the mean, what is the standard deviation, what is the minimum value, and all these things. So here you can see like the mean income is somewhat in this range, and it's in dollars actually. And the median house value is this. So similarly, in this case, it might not make some sense, but as we move ahead, these values would make more sense to you. Now you see for this categorical column, you have all these values as NaN because for categorical variable, our system cannot tell like what is the mean, what is the standard deviation. Rather, it gave us the number of unique values we have for this column, ocean proximity. Now, once you have used this describe method and you have the mathematics of your data set, like the mean, median, and the quantiles and standard deviation count, you can find out the missing values. So you check for the missing values, you use the is null.sum, and you found out that all the columns have the value except the total bedroom, and you found there are 186 rows missing here. Now, what do you need to do is you can find out the percentage of how many bedrooms are missing. So you see that there are 1% bedroom information missing out of the data set. So in some cases, some of your problems, you can decide to drop this completely and it might not make a difference. But if you're solving a very critical problem and you have very less data, you need to think of different ways. How can you fill in the missing values? I'll come to this later. Now we'll check for the categorical features. So I see that ocean proximity has categories and I print all the categories and I see the count for each category. And I see that I have most data points for this category. So these are my observations. Now I can go about plotting graphs and making some insights. So the same thing which I printed here. Now this might be like it might not look pleasant to your eyes, but this seeing this graph, you can instantly say, oh, this feature has the highest number of value, and this feature iron we don't have much data for this. Like not many houses are near island, so this is what you can gather the insights. Then you can find correlation. So what is correlation? The correlation is basically the relationship between the two features. So for example, if I show you the graph, like plot, I've made a heat map. So in this heat map, if you observe, like the higher the value close to one, it shows high correlation, and lower the value it shows, like zero shows no correlation, and -1 again shows high correlation. It signifies negative correlation. So one means higher correlation, highest correlation. If the value of feature x increases, then the like x1 increases, then the value of feature x2 also increases. So consider this feature like total bedrooms, and if you see this total rooms, it has correlation of 0.93. So what does it mean? If the number of bedrooms are more, obviously the total number of rooms will be more, and this is what you can identify. Now there can be another feature which says if the total number of bedrooms are more, the number of rooms are less. So I'm just considering hypothetical situation. So this shows negative correlation. And the first example where both the values were increasing shows positive correlation. So in case you have, say, thousands of features, it would be quite a hectic task to build a model uh, for data set which is having so many features. So you can do one thing if your features have like show very high correlation, you can drop one of the features because both would result in those same prediction values. You can drop one of the features and you can only continue with one. In our case, we don't have these many features, but that's how you approach the problem in GeoCode. Now we can even plot some scatter plots, like we can just plot things around, and where I've plot the latitude and longitude, and I see that this entire house data, these points, data points are the housing data. It resembles with the map of the California. If you see the map of the California, it would look something like this. So this is how we come to know about the data set. Now, if you use this metric hue here, you see it colors like it gives a darker color points which have the higher median value. what do you observe it that the houses that are near the ocean, they are cost their cost is high compared to the houses that are far away from the ocean. So this is the insight which I have extracted after performing exploratory data analysis. You can even further categorize this. So see how beautiful we have the graphs, and I've even documented these uh, these results. I'll just skim through them. You can read all of them in detail. I'm just providing you a high level overview so that you know. Now there is this pair plot which plots graphs between feature, every feature against every other feature. So based on this, you can find see here. If you see the total number of rooms and the total number of bedrooms, this would be if you see that as the value increases, both of them are increasing. So there is positive correlation here. This signifies positive correlation here. Now we'll move to the next step. Now we have performed exploratory data analysis. Now there is no limit to what you do in exploratory data analysis, and it all depends upon you or the data scientist, how well he analyzes the data and gathers the useful insights that can help us making our model better. We have done with the exploratory data analysis. We'll start with the next step, that is data preprocessing. Now, what is data preprocessing? As I told you, we need to handle missing values. We need to encode categorical features. We need to make these categorical features as numerical features, and we need to scale numerical values. Now, what do I mean by scaling numerical values? I'll explain this within a while. So, the very first thing what I'm doing is I have separated my data into the features and the prediction. So I have taken out median house value and I've assigned it to the training label, which means our you can consider this to be the y or the output which the feature which we want to predict. So yeah, this is what it is. So I've divided my data set into two parts, X and Y, where X is my input data and Y is the training label or the median house value, which I need my model to predict. So we have separated this. Now we'll do everything only on our features and we'll not touch this prediction because we don't want prediction to be altered. We want to keep it as it is, though. So now, how do you handle missing values? So handling missing values, you have multiple options. Either you can remove them completely, as I gave you, like you can remove all the rows that have the missing values, but it can result in data loss. So what you can do is you can fill those missing values with some like with average value or what is the most frequent, most occurring value in that column. So you can fill it with that, or you can even leave them as they are. Now, leaving them as they are doesn't give us good results in case of using a lot of algorithms. But for if you're using a tree-based algorithms like random forest or XGBoost, so it gives you good results and they don't they don't get affected by having missing values. So in order to fill the missing values, we'll go by this approach. We'll fill the missing total like number of bedrooms with the average number of bedrooms we have for that column. So what we'll do is we have this library or this method called simple imputer in from the sklearn library, and we'll import the simple imputer class. And before we even go about doing like filling in the missing values, we need to make sure that we have only like numerical data columns in our data set. So we'll just draw portion proximity and we'll create a new data frame which has only numerical values. So I have done the step. Now what I'll do is I'll create an object of simple imputer and I'll specify that I want the missing values to be replaced by the average value or the mean value. And in this object, I'll call the method called fit transform. Now, what does this fit transform does is there are two words, which is fit. Now, fit means computing the average. You use all the column values, existing column values, and you compute the average. And transform means mapping that average or assigning replacing the missing values with the average. This is what transform means. So you have called fit transform, you have imputed or you have replaced fill in the missing values, and then you just like go about creating a data frame so that you can return this. Once you have done this, we'll go further. We've handled the missing values, and I can print and see that there are no null value present in our data set. We have handled missing value case. Now comes encoding the categorical features. Now, you saw that ocean proximity has a lot of like it has string values and our model cannot understand this data. So one thing which we can do is that we can create a mapping. For example, I assign number 0 to this category, 1 to this, and I can replace these values with these numbers. And if I do this, I can do this step using ordinal encoding library. So using in sklearn, we have ordinal encoder, and ordinal encoder does this. So you import ordinal encoder class, you create an object, and again you call the fit transform method. You pass in your input data. So what it will do is, if you observe, it has encoded these values and it has replaced. But what happens a lot of time is that the model considers the value 4 to be the higher value and 0 to be the lower values. And it gives priority to this number 4, which is wrong. We have not given any order. We just gave some number to convert that value to numerical value. So to avoid that, we have another encoding method which is called as one-hot encoding. So what does one-hot encoding do? It it creates a matrix. So what it will do it if we have 5 unique values, it will create a matrix like matrix which will have 5 rows and like 5 columns, and it will assign this binary value to the first category, then this value to the another category, and some this kind of value to the another category. So this is how we encode our value. So here I've used one hot encoder. I've imported this again the class. I have created the object of that class and I've called the fit transform method. You see the code is it's similar. The pattern is similar. So once you've understood the basics, you can write anything in the code. You can just go through the documentation and you can keep on writing things and understanding. So this is how our now categorical features look like. Now comes the scaling part. Now, why do we even need scaling? So I have an example. Can you confirm if you're seeing the presentation right now?
Yes, go ahead, Jyoti.
Yeah.
So suppose if you have, suppose if you, these are some person and you have this salary and this is your age. You want to make some prediction. Now, what you observe here is that the value of your salary is in dollars and the age is in a metric which is years. Now there is a lot of change in salary, like $10,000 change, and the change in this age is only 1 year. Now these values don't signify that this feature is increasing n number of times than this. Rather, they both are different units, so we can't compare between them. So what will happen is if you use this, if you feed this data to the model, it will make a very large change for your salary, even for a very minor change in your age, which is wrong because they're not at all related. So, in order to avoid these situations and in order to avoid your model being affected by the units of the data which you have, we can make use of scaling. So, we can scale our data, and this is termed as feature scaling. And we have two methods to do this. One is normalization and other is standardization. So if you perform normalization, what you do is you take each and every value and you subtract it by the minimum value and you divide it by the maximum minus minimum. So this is what is normalization. So what it results in is that all your values come in the range of 0 to 1. Now, there is another method which is standardization. In this, you subtract each and every value with the mean of all the values for that column, and you divide the standard deviation. And what it does is it brings down all the value in the same scale. So even this column, and n number of columns you have, all those will have the values in the range of 0 and 1. So this is what is known as feature scaling, and this is what we'll implement in our code as well. So I think I'm hoping my notebook is visible again. So I'll show you how do we implement this in code. So in order to implement this in code, we have min-max scalar to implement normalization. Just import this class. We again create an object and we call the fit transform method. So once you call it and you print your data, you see it has completely changed from where we started and where we are right now. You see all the data is in the range of 0 and 1. So this is how you implement normalization. And if you want to implement standardization, you can just import standard scalar class and you can create an object and again call the fit transform method. Now in this case, you see that we have the values in the range of say -3 to +3. You see some negatives and some positives. Now, based on like our problem statement and our needs, we need to decide whether we need to use either standardization and normalization for like you need to either go with one approach. I've shown both of them just for the sake of completion and for demonstrating. Now, one concept which is quite used nowadays is that you see we wrote a lot of code in past few cells. We can avoid that. What we can do is we can create a pipe or a pipeline. And in that pipeline, we'll tell that this is your step one. Once you have done the step, move to the step two. And once you've done the step, you can move to the step three. So, how I have explained here is that consider you make a pipeline for doing all the steps, all the pre-processing steps for all the numerical data, and then you can create a categorical pipeline to do all the pre-processing on your categorical columns. Then you can combine these pipelines and create one pipeline. So it's very easy and very simple to implement, and we can cut all that code which we have written, and we can make our notebook like really nice and clean by using this pipeline features which scikit-learn is offering. So you just need to import this pipeline class, and within this you need to pass in the steps. So the first step which we are doing is we are filling in the missing values. The second is that we are scaling the data. So once we have created this pipeline, we can just fit transform our data set to this pipeline. Now, if you see this, it has your data in the same form which you saw above in the code. So you see how we reduced the amount of code. We've written just this much of code for whatever we saw till now. It's just literally 2 lines of code for everything. Similarly, you can create a categorical pipeline and you can do the encoding using that pipeline. So I've used this categorical pipeline. You can add more steps based on what the requirements is. For just demonstration purposes, we're just using one hot encoding here. We don't need anything else. Now what you have two pipelines and you can simply create your final pipeline. For creating the final pipeline, you'll use this column transformer method and you'll just pass your pipeline and your data set to this method and you have your final pipeline or the final data set ready for your model to be fed to. Now, this entire process is the main part, and you see, if you see my scrolling icon, you see it's just below. So this all takes a lot of time, even if you're approaching a real world problem. And model building is literally like way too simple than all the steps. And now we'll proceed to the model building part. We completed all the first 4 steps. We understood the problem. We collected the data. We did exploratory data analysis, and we processed the data to make it ready to fed to the model. Now we have our final pipeline and we have our final data. Now I'll start. How do we choose and train a model? Now here in this problem statement, you see we need to predict the value or the income of the person. So this problem statement is a regression problem because I'm going to predict some like continuous values. So I'll start with the very first regression algorithm, and I hope my slides are visible to you guys. I'll start with the simple linear regression first. Now, in what is simple linear regression? Suppose if you have the data points, so these diamonds represent your actual data points. You can just consider two features for now, X and Y. Suppose if you have the weight of the person and you need to predict what will be the height of the person. So you have one feature called weight and you need to predict what will be the height. And you have some data points. Now you want to make a model. So in order to solve this problem, what you can do is you can create a model which has this value. So your value for prediction can be y is denoted by y hat, and here I have this intercept and intercept plus slope multiplied by the feature. Now this is the equation of a simple line, which is y is equals to mx plus c. If you start like you all might have studied till your schools, like what is y is equals to mx plus c. In order to solve this problem, what I'll do is I'll make a line. I'll make a model. I'll just make a line that passes to all these things. But which line is the best one? Is the blue one the best one, or the red one the best one, or is the green one the best one? How do we know that which line is the best one? So the simple linear regression algorithm, what it does is it finds out the best fitting line for your data set, and it uses like that line would serve as the model for you. So this is the diagram which represents what do we mean by intercept. So intercept is how far we are from the y-axis, and then the slope, basically how is the inclination of the line with respect to the x-axis. So this theta is called a slope, and this is the equation of the line. These are your points, and this is your actual point. And if you drop in this point here on the line, this is your predicted point. So this is your simple linear regression model. Now there is an algorithm. So initially the algorithm goes as like it starts with some it starts with a particular line, and it will keep on improving these theta 1 and theta 2 values using an algorithm called gradient descent, and it's quite a heavy algorithm, and it would take me another session to explain that algorithm. So I've not covered this, just walk you through what the basic mathematical intuition of this algorithm is. And if you want to read in detail, I'll provide the reading material, or you can always like Google search. So this is the model. We have made the model, and this is what we have built. So for this point, our model is going to predict this values. So there will obviously be some errors in prediction, but you observe if any point lies on this line, it would predict it very correctly. So this is what simple linear regression algorithm is about. I'll show in code how do we implement this, but there's another algorithm called multiple linear regression. Now, simple linear regression, I took the example of height and weight. So you knew the weight of the person and you have to predict the height of the person. Now, in simple linear regression, you only have one feature. Just remember, it's very simple, just one feature. In case you have multiple features, that we have in our case in our California housing data set. So we term that as multiple linear regression problem. So we use multiple linear regression to solve it. So it's just saying that it is not a 2D plot like that. You have multiple slopes coefficient for each of the feature, and then you have intercept, and you need to make this model to make predictions. This is multiple linear regression. Other than this, there is another thing which is called as polynomial regression. Now, the data, if you see here, now this data is in linear form, like you can plot a line and you can create a good model. But what happens in case of polynomial linear regression is if your data is non-linear, it it doesn't fits the single line well, if your data has some features that suppose if for increase in your target variable, the for increase in your features, the target variable increases exponentially. So it means that there is no linear relationship between them. So basically, you need to plot a curve. So in this case, it looks like a parabola. So this kind of problem statements, we can solve this using polynomial regression. So this is the equation of polynomial regression. So you see that y here is the target variable here is has the value x beta not your intercept plus the slope of the line and x1. Then you have x1 square as well. So this shows the nonlinear relationship. So this is what is simple linear regression, multiple linear regression, and polynomial regression. Now, how do we implement this in code? So it's very simple to implement a linear regression model. You just need to write one line from scikit-learn.linear model library. You just need to import linear regression class, and then you create an object. So I've created drag model as the object of this class, and I called the fit method. Now, what does fit method do? You have this model. Now you make this model compatible for our use case. So you pass in your data, your training data, and you pass in the expected value for the training data. You pass in the target variable. So you see, we have used label data. You passed in X and you passed in Y, or the expected output, and you gave the model and you said just fit yourself according to your data, according to this data. So if you run this, you'll see some output of this kind, and your linear regression model is ready. You saw it's just so simple, it's just two line of code, but you had to do a lot of steps there, and you have to know the mathematical intuition behind each and every ML algorithm so that you know which model to make use of while building, and which model would solve your problem very easily. So we have covered the regression model. Now what we'll do is we'll move to the next regression model, which is decision tree. So what decision tree is about? So in our life, whenever we are stuck at a situation, what we are most likely to do is we'll decide whether to go around this or not, like whether we should take the step or not. We all do this in our heads, right? Whether we should start learning Python or not. Now, once you've decided you start learning Python, you'll decide whether to go with this channel or to go with that channel. Then you'll decide whether to go, like you should start learning ML or you should start learning, say, backend. So all these decisions you take, and then you come to a final conclusion that, yeah, I should go and do this and this. So this is what decision tree is. It's similar to how we humans make decisions in our real life. So just consider an example. So
So,
before I even start,
Jyoti, have you changed the screen?
yeah, yeah, no, right now I've just changed it right now because I was just explaining it. So can you see my screen now? Decision trees, some data here, slides.
Yes.
So before I even start with decision tree, I want to inform that the algorithms which are known as decision tree and support vector machine, random forest, these algorithms work for both regression problems as well as the classification problems. So I'll be covering either of the example, and the only difference lies in changing the word classifier or regressor in code. And I'll tell you how do we go about decision trees when we're implementing regression. So just consider an example. You have this example wherein you have this data set of cats and dogs. You have some cats and you have some dogs, and you have their features, like what is the shape of the ear, what is their face shape, and do they have whiskers or not. And this output is whether it is a cat. If it is a cat, it will say one. If it is a dog, it will say zero. So this is what your data is about. Now what you do is that you make a decision tree. So you decide that we'll start with the ear shape. We'll see whether the ear is pointy or the ear is floppy. Now, if it is pointy, I'll go and check the face shape, that whether the face is round or the face is not round. In case the face is round, we call that animal to be a cat, and if it is not round, we call that animal to be not cat. Similarly, on right hand side also, we if the ear shape is floppy, we then check whiskers, whether whiskers are present or absent. So we check whether whiskers are present. If they're present, then it is a cat, and if it is not present, then it is not a cat. So we made this decision tree. So you see, it resembles the structure of the tree, and we are just making decisions. So it's called as decision tree. You can pass a new example. You can pass a new cat, which will have this feature that's pointy and round, and then and it has whiskers present. Now you can decide like whether it is a cat or not. So if I go and see ear shapes, it's pointy, so I'll go downwards. I see the face shape, it's round. So yes, this animal is a cat. So this is how the decision tree works. So we can have multiple decision trees. If we in the previous slide, I started with the ear shape. I can even start with the face shape, or I can start with the face shape, then I can check the ear shape, and then I can check whiskers. Now, which decision tree gives us the best results? So all this questions or all these situations is handled by the decision tree learning algorithm in itself. You just need to write one single line of code. But if you go in depth of decision tree, there is a method to decide which feature should I take here. Should I take ear shape, or should I take face shape, or should I take whiskers first? So this is the entire process which I've explained you, that we started here. We have all these data, and then we like categorize the data. We further keep on dividing the data until and unless we move, like we reach a situation where in a particular side we only have all cats or we only have all dogs, and we are able to segregate between cats and dogs. So this is what I've depicted through slides, and you can go through these slides. I'll provide you the link. And as I told you, the most important decisions which we need to make is which feature should I take first, and like which feature should I take first and make the split. Should I take your shape? Should I take face shape? Or should I take whiskers? And when should I stop splitting? Should I stop splitting once we have all cats in one side and all dogs in other side? Or we can allow some misclassification so that our algorithm does not predict too well. So these are the two important decisions which you need to think of, and we have the internal working of decision tree that solves all these questions, all these problems. And again, to implement this, we have very simple code. So I'll just walk you through the code. Now, covering the internals of decision tree to that extent would take me another class. So I've just given you an idea of what decision tree is. So I'll share the code. I hope my code is visible right now. Now, in case of regression problem, what happens is here we were predicting whether animal is cat or dog. What we do is for each category we compute the average value, and we store that average value as our final result. So this is what happens in regression. So in order to implement decision tree regression, you need to import from sklearn.tree decision tree regressor. And if you want to implement classification, you just need to change this word regressor to classifier, and the algorithm does everything on itself. You just create an object of this decision tree regressor class, and then you just fit. You ask that like object that, hey, just fit in my data set. This is my data. This is my training data. This is my expected training output. Just fit this model according for working on this data. So you call this decision tree model. Now, this is how you train the decision tree model. Now, it's like again very simple implementation of code. So once you've implemented decision tree, you can like just use those 3 lines of code to implement it in any problem. Now comes the second, like third algorithm, which is random forest regression, or we can even call classification. Like we can solve classification. Only thing we need to change is the last word, regressor or classifier. So random forest regression is nothing but just if we make use of multiple decision trees instead of making one decision tree, we make use of multiple decision trees so that see in this figure you can see we have multiple decision trees and we combine the results of all this decision tree and then we predict the output. So then it becomes random forest algorithm. So you just pick some k random data points from the training set, and then you build decision tree for these k data points. And suppose if you build 10 trees, so you will do repeat this process 10 times. For 10 times, you will take some random points and you will build decision tree around those data points. So you included some randomization in the process and you're making use of 10 decision trees. So many trees make a forest. So that is why comes the name random forest. Now using this random forest, you can model, you can make predictions for your new data point. And obviously, like this is going to be better than decision trees. But in some cases, decision trees might work even well than random forest if your data is exceptionally very less or small. So this is what you've learned till now: linear regression, polynomial regression, decision tree, and random forest. So let me walk you through the code. How do we implement decision like random forest regressor? Now, in case of classification problem, what we do is that we take the class which is predicted the more number of times. Suppose we have 10 decision trees, and out of those 10 decision trees, 6 decision trees said that this is a cat, and 4 said that this is a dog. So I'll go with the majority one that this is a cat. But in case of regression, what happens is if your model predicted 10 different temperatures or 10 different house values, it will just take the mean of all those house values of those 10 decision tree, and the mean of those house values would be the final output. So this is how we write in code. We just call this class uh, from sklearn.ensemble method. We import random forest regressor, and then we create an object, and then we fit that model for our data for our data set. So if you run this, you will see the output of this kind, and yeah, your model is ready. So we've covered a lot of algorithms now. I'll We have two more algorithms, naive Bayes and support vector regression, which I'll go about now. So, yeah. To support a vector machine, what this algorithm does for you is, as you saw above, in case of support vector regression, I'm missing this slide, just give me a second. Just a second, I'll just do put some image to explain. Yeah, can you all see some image? Sharing one tab, it has this image of a graph, support vector machine algorithm.
Yes, Jyoti.
Okay. So now what we see here is that in support vector machine algorithm, what happens is, suppose if you have two categories, a male, consider the male example, if it is spam or not. So what happens is that you take a margin line and then you make a tube around this line. So what this tube will be, the tube has the maximum distance from the data points that says your mail is spam, and another like equidistance from the data points which say the mail is not spam. So anything which lies within the range of this tube is not considered as an error, and it is considered to be okay. So these points which support this tube, which held this tube or which lie around the boundary of this tube, is known as support vector. And this entire process of using this algorithm is called a support vector machine algorithm. So this is like really very simple, and there are variations of support vector machine algorithm. Like we can have kernels in it, we can have linear, non-linear kernel or polynomial kernel, and it is like advanced support vector machine algorithm, and it's quite detailed. So I've shared the basic intuition. Now we'll go and see how do we implement this in code. So in order to implement support vector regression, all we need to do is we need to just call SVR. So this is support vector regression. And in order to implement classification, we just change this R to C, which stands for support vector classifier. So I'm calling this support vector regression. I'll create an object of this class, and then I'll fit my data set. I'll ask this model to fit in according to my data. Your support vector regression model is just ready. So this is how you go about support vector regression. Now we'll go through our last algorithm, which is like naive Bayes algorithm. So what happens in naive Bayes is that this algorithm is based on very famous probability algorithm, which you might have studied in your colleges or high schools. That is Bayes theorem. So what does Bayes theorem says is that given a point, given the value of x, what is the probability that the event y can occur? And this is the formula of the Bayes theorem. So I am skipping through this formula because like you can go and read about this in detail. I'll just explain you in a very simple way through an example. So if you see that I have a data set, and what this data set is about, it's about whether a person goes to play golf or not. So what happens is you have the data for the day. So suppose if the day, like it was the outlook for the day was like it looked like it's rainy day and the temperature is hot and it's the humidity is high and there is no wind, so the person doesn't goes to play golf. And other case, suppose if the temperature, like outlook or the day looks like it's overcast, like it's shadowed, and the temperature is hot, humidity is high, but it's not windy. On the overcast day, the person goes to play golf. So this is your data set about. Now you want to predict, like given the day that you want to predict basically given some certain conditions, whether it's humidity, wind, or say it's rainy, it's the temperature is hot and the humidity is high and the day is windy. What is like will the person go to play golf or will the person not play golf? So what you'll do is you have the speeches with yourself and you need to predict whether you are going to play golf or not. So what you can simply do is you will find, given the today's condition, will find out what is the probability that the person goes to play golf. And how can you do this? You can find out the probability, the number of times the day was sunny and the person went to play golf. You can find out that probability, and then you can multiply it with the probability that number of times like the temperature was hot and yet the person went to play golf. So based on every feature and given the day, like given this condition and the number of times it's yes or the probability, you can find it out and you can multiply them all and you can divide with the total probability and you'll get what will be the probability that given these conditions the person goes to play golf. And similarly, you can find out the probability whether the person doesn't play goes to play golf, whether it's a no that today person will not go to play golf. So Once you have computed these probabilities, you'll find out which is the higher value. Suppose if like for the yes, the probability was 0. Say it's 0.0001 in this case, and for no, the probability is 0.006. Now you see the probability for the person to go out and play golf is higher than the probability for the person to not play a goal. So what you can do is like the higher the probability, that could be the chance that person goes to play golf. So if the probability for the yes is higher, then the person will probably go out and play golf, and your model will predict yes, the person is going to play golf. But instead, if it was reversed, that the probability for no would have been zero point 0.6 and the probability for yes would have been zero point 0.3, then our model would have given the result that no, given these conditions, the person will not go and play golf. So this is how the naive Bayes algorithm works, and it's completely based on the Bayes theorem. And it's just that in Bayes theorem, here I have shown that there is only one x, but in case of naive Bayes, you have multiple features. And given these features, what is the probability of the occurrence of this that event is what you are going to make the prediction about. Now, I'll walk you through the code that how we are going to implement this naive Bayes algorithm. So again, it's like very simple. Now there are very like many variants of naive Bayes algorithm, but what we're going to implement is Gaussian naive Bayes. We just import this Gaussian naive Bayes from the scikit-learn library. We create an object, and again we fit in the data, and we are ready with our model. This is it for the steps. So you see that the steps to build a model are really very simple, but the idea behind building these kind of models or the mathematical intuitions is really very important when it comes to machine learning. So we completed the steps. We have built various models. Now you have so many models, and you need to decide. Okay, you have trained your model. You need to decide how well is the model performing. You need to check whether the model is good or the model is bad. What is the output of the model? So you need to move to the next step, that is model evaluation. So how do you evaluate the regression models? So there are three main techniques for evaluating the models, like regression models, like most famous ones. And like there are many methods for evaluation, but I'm going to discuss three. So one is mean squared error, another is root mean squared error, and this is mean absolute error. So for example, if I just give you quick example of how do we understand mean square error. Yeah, in this case, if you see that in this graph, the observed or the actual value was here and the predicted value was here. So what this mean squared error says that compute the distance between these values. And higher, like if you have the line which is far away from this actual point, higher will be the error. The root mean square error says that you just take root of the distance, and mean squared error says don't take the actual distance. So distance can be computed like many ways. There can be Euclidean distance, and the formula for the Euclidean distance is this, and there can be Manhattan distance. So like these are different formula for distances, and you can like search about these terms. So if you found a distance this way, it says this is the mean squared error. And if you just if you don't square this value, you just take the absolute value, it's known as mean absolute error. So you what we basically do is we take the actual prediction, actual value, and we subtract it from our predicted value, and whatever we get or whatever difference we get, that is termed as our error. So what I've done is I've taken all the models and I've made a function that calculates the root mean squared error. And I'm just calling this function to make predictions, and we'll see what the error looks like. So if you observe here, you see that you have a very high error values. Now this is because we have used the models as it is, but there are certain parameters that these models can accept, and you can play around those parameters. You can change those values, and then you can make those algorithms work even better. So, if I am to give an example, consider random forest. So if your model doesn't performs very well, you can increase the number of trees, right? And you can increase the number of trees, you can increase the number of leaf nodes, and some kinds of these parameters to see how to improve that models. Now, in case of decision tree regressor, you see the value 0.000, and this looks really strange. So it might be a case that your model has overfitted, or your model is doing exceptionally well, and your model has learned the data, and there is a chance if you give a new data, the model doesn't perform that well. So I'll discuss these words overfitting, underfitting tomorrow. For now, you can just see that these are the error values which I've got, and the error I think is least for the random forest regressor in our case. So yeah, this is how we evaluate our regression model. So we have completed our regression notebook. Now, similar to this, I have made a notebook for classification, and I have used a different data set. I've used a classification problem here. So what you all can do is you can go through this classification notebook by yourself, and if I'm to show you the code, this is all exploratory data analysis, and then I have done some data pre-processing. So these all steps which I've discussed are going to remain same. So you can just go and see this notebook in detail. If you see here, I've implemented support vector machine, and I've replaced that regressor with classifier. And then I've used decision tree as well. I've used decision tree classifier, and it performs really well. And what I haven't discussed till now in classification is two algorithms. One is logistic regression and k-nearest neighbors. So let me go through that. So there are two more algorithms which we can use for solving classification problems, and these algorithms are linear, like logistic regression, and k-nearest neighbors. So I'll just explain you in very simple manner through examples, and these slides are very descriptive. You all can go through these slides in details, but what I'm doing is I'm explaining you through examples so that it's easier for you to grasp the things. So suppose if you were to predict whether a person is having tumor, and you want to predict whether it's a malignant tumor that's harmful or not. So to solve this problem, if you were to make a straight line, you'll see that it doesn't turns out really well, and it gives a lot of wrong predictions. So to solve this problem, or to recognize whether the mail is spam or not, we have something called as logistic regression that makes use of a mathematical function called sigmoid function. And what it does is it looks something like this. So in this case, you have some threshold value, and anything above that threshold value, so you pass in your model in this mathematical equation. If this value turns out to be greater than your threshold value, the model predicts 1, and if it is lesser than the threshold value, the model predicts it as 0. For example, if you've taken some example and your model predicted 0.7, so what will it give you? It will say that yes, this mail is a spam. It will label it as 1. But if you got the value 0.2, it will say no, this mail is not a spam since it's lesser than 0.5. So it will say it's not a spam, and it will label your target variable as 0. So this is what is logistic regression. So, if I'm to even explain more, what we do is we basically construct a decision boundary that makes segregates your two classes. And these decision boundaries, the example I took, this is a linear decision boundary, but you can even have non-linear decision boundaries as well. So in this case, it's the equation of a circle. So you can make a non-linear decision boundary using logistic regression, and it's very powerful algorithms which is used to solve classification problems. Now, this is how do we so in regression, I told you, right? We compute the distance to identify the error. Similarly, in regression, we have this huge loss function. So it looks scary, but it isn't actually. So this loss function or the cost function is known as logistic loss function, and it's known as cross entropy loss function. So I just added this slide for the sake of completion, and again, it's like it will take time for me to explain you this cost function, but you can like always search about this and read more about this. So now this is theoretical explanation which I've added. So I'll just move on to my classification slide and I'll show you how do we implement logistic regression. You see, you can see that I've just imported logistic regression from the linear model library and I've created the object and I've you called the fit method to fit my model, like fit the model according to the data which I have. So this is how we implement logistic regression, and it looks really simple now, right? So this is logistic regression. There is another algorithm called k nearest neighbors. Now, suppose what this algorithm is, I'll just again explain you through an example. Suppose if you have two categories, say spam or not spam, and you have a new data point. You have this data point. Now you want to know, you have a new mail, you want to know whether it is spam or not. Now, how do you go about this? How do you decide? So, as the name suggests, k nearest neighbors. So, what we do is we select k neighbors. Suppose if the number k, if k is 4, I'll select the 4 points around this new data point, the 4 nearest points, and the number of the points that are more. If the red points are more, I'll label this new data point as category 1. And if the green points, like if there are 3 green points that are closer to this new data points, I'll label this as category 2. So in our case, if we compute these values, we found that there are, say, 3 data points that are in category 1, which are closer to the new data point, and only one point of category 2 that is near to the new data point. So you can simply predict the new data point to belong to category 1. This is what I have written in terms of the steps. So you just choose k number of neighbors and you take the k nearest neighbors from the data point and you calculate, say, Euclidean distance, and you count the number of data points for each category, and whichever category has the highest number of data points, you assign that new data point to that category. So it's very simple algorithm. Now the thing which we need to think upon is how do we decide the optimal number of k? So how do we decide how what should be k? Should it be 2? Should it be 4? Should it be 5? So this is a point of discussion. Now these are some slides which I have added here, and it's again like you can go in depth of k nearest neighbors. So this by like now we've like completed the classification algorithms as well. And here, if you see, there is a different method to evaluate the classification algorithm. And the most famous way to evaluate classification algorithm is making use of confusion matrix. Now it looks scary, but it's very simple. Now you have actual values. So consider your actual values were examples whether the mail is spam or not. So if it is a spam, it means positive, and if it is not spam, it means negative. Similarly, your model must have made some predictions. So here I have my predicted values, which says the mail is either a spam, and our model predicted that the mail is not spam. So we make this matrix 2 cross 2 matrix, and we say that whether the actually the that mail was spam, and our model also predicted that mail to be spam. So it is a example of true positive. Like the predicted value is also positive, and in actual that value is even positive. Now consider the situation that in actually the mail was not spam and your model predicted it to be a spam. So that becomes your false positive example. So it means that the predicted value is the true, but in actually like the predicted value is spam, but in actually your mail was not a spam value. In actual it was false. Now the third is like you predicted the model, like your model predicted the mail to be not spam, but in actual it was a spam mail. So this is wrong, right? So this is known as false negative. And if your model predicts the mail to be not spam and in actual the mail was also not spam, then it is termed as the true negative. Like the predicted value is also negative and the actual value was also negative. So this is how do we evaluate classification problem. Now I'll go through the code. So I'll show you how do we evaluate. Now I have added I have added these descriptive notes. You can go through this, and here I have called this cross validation score method to so I'll skip through this cross validation and just yeah, I have added more metrics like accuracy, precision, recall, F1 score. So this here I've explained the confusion matrix and the accuracy, like precision and recall, you can I would recommend like you can go through it and read it by your own. But this is the concept of confusion matrix which I've already covered. So in order to evaluate your model, what you'll do is you'll just import confusion matrix and you will give the training labels or the actual y and your prediction labels, whatever predictions you made. And you see this matrix. Now, in our case, we were having only two categories, but in the data set which I have taken, it has four classes, four labels. So that is why you see the 4 cross 4 matrix here. So what your assignment for today would be, you need to go through this notebook. And here I have implemented only two algorithms or two or three. So decision tree, support vector, and logistic regression. And I would want you all to implement naive Bayes classifier, random forest classifier, and k-nearest neighbors. So this is what your assignment is going to be today, and it's not quite a heavy task. So it is only for your good. Like you'll go through this entire data set, you'll understand it well, and if you have any doubts, you can always reach out to me. So by this, we complete the section of supervised learning. And Jaya, should I stop now and should I come cover the unsupervised learning? Tomorrow I have only one algorithm for it and I'll start with neural networks tomorrow, or should I finish unsupervised learning today? I think it's a lot for today.
Yes, Jyoti, is the presentation completed?
Yeah, like I have only unsupervised learning algorithm left. So that is a clustering algorithm. So
So
maybe
you
I
are
can
taking
pick
that
it up.
in tomorrow class.
Yeah, I'll take
And
it
what else
tomorrow.
remaining for tomorrow session?
Just introduction to TensorFlow and neural network.
Okay, okay. I'm just
Yeah.
stopping the